Since we can't exactly see electricity, it can be kind of hard to keep track of what's going on inside of a circuit sometimes. Terms like voltage, current, and resistance are helpful for describing it, but if we want to actually measure those quantities ourselves, we need something to act as our electrical eyes and ears. Something we call a multimeter. Though the design has been updated and improved since then, the basic way we use them has pretty much remained unchanged. Two probes, one negative and one positive, are put in contact with a circuit, and then a measurement is displayed on the body of the device. Analog multimeters are still made, but digital multimeters are far more common nowadays, and they offer a lot of handy features.
The two types of digital multimeter you're most likely to run into are auto-ranging and non-auto-ranging, or manual range. Manual range meters require you to know the approximate amount you'll be measuring and set the dial to that appropriate range. Auto-range meters take a little bit longer to settle on a final measurement, but in general, they're much easier to use. Just set the dial to the type of measurement you want to make, and it'll get the range automatically, as the name implies.
There are a lot of different brands and models out there designed to measure a wide variety of different things. But when working with electronics, you'll likely only need to measure a few basics: continuity, resistance, voltage, and current. Let's go over how to do that, shall we? The simplest and probably most useful thing to test with a multimeter is continuity, whether or not 2 points are electrically connected to one another. Continuity testing is super helpful for troubleshooting soldering work, circuit board traces, or even if an old cable needs to be repaired.
First, switch the control dial to the continuity setting. This is usually marked with a diode or audio symbol. Most meters can produce an audible beep to indicate continuity, which is handy when you need to keep your eyes on your work. Connect the black probe to the common ground terminal and the red probe to the voltage ohms diode terminal. Make sure whatever you're testing is unpowered, then connect the two leads to each test point. For example, the positive voltage and ground traces on my proto board should be separate and not produce a beep. But they did, so that means I have a short somewhere. But where exactly? Oh, maybe this giant solder bridge right here. Yeah, I'll have to desolder that later.
Technically, when I measured continuity, the multimeter was checking for a very low electrical resistance. Anything below about 100 ohms would give a positive continuity reading.
To measure resistance, I just turn the control to the resistance setting, marked with the omega symbol, the symbol for ohms. As with measuring continuity, it doesn't matter which way I connect the probes to my test points. Either orientation will work fine. This resistor is marked as 1000 ohms with a 5% manufacturing tolerance, which means its actual resistance could be 5% more or less than 1000. Whoa, it's actually pretty close. 1006 ohms. It's a pretty precise resistor. To measure voltage, I'll once again check to make sure my probes are connected to the proper terminals. I'll then simply switch the dial to voltage. Some meters might have a separate setting for AC or DC voltage. So how about we test a battery? Black probe goes to ground, negative battery terminal, and red to the positive terminal. 8.95 volts. Not bad. Definitely usable. Measuring current is quite a bit different from measuring voltage or resistance. Electricity needs to be routed through the multimeter itself, which makes the setup a bit more complex. For starters, even though this is an auto-ranging meter, I need to choose a basic range for current measurement. The milliamp setting will work fine for a small LED test. Then I'll move the positive probe to the milliamp labeled terminal. I'd use the terminal rated for 10 amps if I thought I might be measuring anything more than 500 milliamps. Finally, I'll break the circuit at the point I'd like to test and connect the positive probe to the side supplying positive voltage and the negative probe to the side connected to ground. Looks like my LED is drawing about 18 milliamps, well under the maximum amount it's designed to handle.
You'll also find multimeters designed to test capacitance, transistors, frequency, temperature, a long list of other things. But for my purposes, simply resistance, voltage, and current have gone a long way. Well, I guess I'll check for some more solder bridges here. Happy testing.